Chapter 7.5, Day 1, we're solving rational equations. You can use cross-multiplying to solve a rational equation when each side of the equation is a single rational expression. So we're going to use this method for these rational expressions. And so notice that we have one rational expression on each side, and so we're going to cross-multiply. So in this case, we're going to multiply these together and then multiply these together. So that's cross-multiplying. So let's do 3 times 4x plus 5 equals, and then the 9 times x plus 1. So then we're going to distribute and solve for x. So on the left side, 3 times 4x is 12x, plus 3 times 5 is 15, and that equals 9 times x is 9x plus 9. So then we solve for x. So let's combine like terms. Let's subtract 9x from both sides. So this is 3x plus 15 equals 9. Subtract 15 from both sides. So now we have 3x equals negative 6. Then to solve for x, we divide by 3. So x equals negative 2. Then we need to look at our restrictions. So what can the denominators not be? So we look at the original. So let's go back to the original and let's look at x plus 1 and 4x plus 5. So on the left side, that's a little quicker to tell. So the denominator cannot be 0. And so if you do x plus 1 cannot equal 0. And so let's subtract 1 from both sides. So notice that x cannot equal negative 1. Because when we plug in negative 1 here, so if we plug in negative 1 plus 1 is 0, and you're not allowed to have 0 in the denominator. So we found one of the restrictions is x equals negative 1. And then on the other side, 4x plus 5. So that one may be a little harder to see. So again, just do 4x plus 5, and that cannot equal 0. And let's solve for x. Let's subtract 5 from both sides. Then we get 4x equals negative 5. And then divide by 4. Divide by 4. And so, the other restriction is x cannot equal negative 5 over 4. So we have our restrictions. Those are our restrictions. And then x equals negative 2. That is fine. So when we're solving, you always want to look back. Is this a true solution? And you could always plug it in to make sure that it equals. But one thing we're going to take a look at and focus on is to make sure that the restrictions, that this value, whatever we get, is not one of the restrictions. And in this case, it's not, right? If I plug in negative 2 here, I am not going to get 0 in the denominator. So x equals negative 2 is the answer. And then you have to talk about what your restrictions are. So I'm going to do one more example, number 3. So we're going to go ahead and solve by cross-multiplying again. So I'm going to multiply these together, and then I'll multiply these together. So this is going to be 1 times 11x plus 8. So 1 times 11x plus 8. And that's going to equal, I'm going to do the x first, x times 2x plus 5. So then we distribute, for on the left side, it's the same. So it's still 11x plus 8. And then on the right, we distribute. Notice we're going to get 2x squared plus 5x. So now we have a quadratic equation. So when it's a quadratic equation, we want to set it equal to 0 and then solve. So we're going to move everything to the right side. Let's keep our x squared positive. So let's subtract 11x from both sides. So now we have 8 equals 2x squared, and then 5 minus 11 is negative 6x. Now last, let's go ahead and subtract 8 from both sides, so it equals 0. So now we have 0 equals 2x squared minus 6x minus 8. Now we always take a look at a GCF. Can we divide something out to make this a little nicer? And in this case, we can divide out a 2. So now we're going to look at 0 equals x squared minus 3x minus 4. Then we use the methods that we know in order to solve or factor. And so in this case, this is factorable. So to solve, we are factoring. So it multiplies to negative 4, that adds to negative 3. So if you still need to do the x method, you can still use that method to help you out. So that is negative 4 times 1. So negative 4 times 1 is negative 4. Negative 4 plus 1 is a negative 3. These are the factors. So we find that it's x minus 4 and x plus 1. Then using the zero product property, x equals a positive 4 and x equals a negative 1. Now we need to look at the restrictions. What can our denominators not be? So let's take a look here. So this one, again, it's a little tougher to see, and maybe you can see the pattern, but just set it equal to 2x plus 5 cannot equal 0, and then do the same thing. 11x plus 8 also cannot equal 0 because you're not allowed to have 0 in the denominator. Then you solve for x. So subtract 5. Get 2x cannot equal negative 5, and then divide by 2. So we find that x cannot equal negative 5 halves. On the right side, if we subtract 8 from both sides, we get 11x cannot equal negative 8. Divide by 11. So x cannot equal negative 8 over 11. So those are our restrictions. And then that means that our answer here, x equals 4 and x equals negative 1, are the answers to this equation. Again, we could plug it in, see if it's true, but for now, let's just focus on whether or not it hits our restriction or not. So now you can do number 2 and also number 1.